Let's understand what are the special variables in Unix along with their meaning. We haven't, I believe, recorded this before. So special variables are the ones that are normally not allowed by a user, like a custom variable. I can't assign a custom variable name which is same as that of the ones that Unix has uh, reserved for its own use. So these are some special variables in Unix. $? Which prints the exit status of the previous command, and I told you this before that 0 value as an exit status indicates a successful execution, whereas a non-zero value indicates a failed execution. Now necessarily when I say failed execution, it may be a failure in the assertion or failure in running the command itself. $! Prints the PID of the last job you submitted in the background for execution. So you can run the commands in either in foreground normally or in background by putting an ampersand against it. $! Would print the PID of the last job that you have submitted for background execution. $! Prints the PID of the current shell executing the $! Command itself. So here I have just logged in. Let me initiate a fresh session to show. I am logging in as Dick, which is also my demo account. Now when I say PS, I logged in. Unix assigned me a command shell after the login process was successful, after the authentication was done. This bash is my command shell. Now why it's command shell? Because this is the first shell that gets invoked. This was decided when my account got created. My account details for user Dick are kept in the file /etc/passwd, and as the last field I can see the shell assigned to me as my default command shell is bash. This is the reason why after a successful login the bash command shell was invoked as my command interpreter. Now if I type echo $$ here, it prints me the PID of that shell. This is what I said here. $$ prints the process ID of the current shell executing the $$ command itself. So who executed, or where did I manage to execute this echo $$? On the current command prompt which is provided to me by bash and which is having the PID as 8575. That's why it's printing as 8575. We'll revisit this topic again in a moment's time once we are done with the special variables discussion. $0 prints the name of the program itself. Typically you are free to use it anywhere in any shell script, whether that shell script is interactive or non-interactive. You can always make use of $0. $0 will print the name of the program itself with absolute or relative path the way you have invoked it. So if I invoke my program using a relative path, it will print the relative path of my program. If I invoke my program with an absolute path, it will print the absolute path to that program. Let's quickly demonstrate. So I said vi program name.sh, and I am adding only one instruction /bin/ksh, which is my shell directive, followed by echo $0. I am marking this program as executable. When I run it now, remember I am running it with a relative path this time. So it prints the relative path of that program. If I would have invoked it with an absolute path, it prints me the absolute path of the program. So $0 from within a shell script prints the name of the program, which could be either relative or absolute. Obviously, depending upon how it was invoked. $1 through $9 prints the value of the command line arguments from position 1 to 9. This we have discussed during the command line arguments discussion. $hash prints the count of command line arguments. $@ or $* for that matter, both prints the command line as is. The verbatim version of your command line is printed as is. I told you the limitation with this $1 to $9 is if your program accepts more than 9 command line arguments, there is no $10, 11, 12, 13, so on and so forth. But one could make use of the shift technique. The shift command itself allows you to shift the positional parameters to the left by one position at a time until the shift is provided with some other argument. Shift can also accept a numeric argument. If I say shift, by default shift is shift by 1 to the left. If you say shift 4, then it will shift the command line by 4 positions to the left. But typically it's often very common to use the shift command as a standalone one without any argument, which means it will shift my entire command line parameters to the left by one position at a time. So assume that I am passing some parameters to my command line. So I am running a script. Let's say I plan to run a script where I want to access any number of parameters that have been passed, and I want to just do a total of it. So I start with a shell directive followed by the logic. So I have initialized a variable sum. Now I keep on adding the value of the positional parameters into the sum variable as long as there are parameters left on my command line in a loop, every time shifting that command line by one positional parameter. So I said while $hash prints me the total number of parameters on my command line is greater than or equal to 1. So as long as there are one parameter left on my command prompt, keep on looping from it. And then I said sum is equal to expression $sum plus $1. I am always accessing the positional parameter with a value as $1, the first positional parameter. Well, I don't have to do anything much beyond this, and at the end preferably I would like to print the total, something like this. When I am done, I am running this, marking it as executable, and then I would run it by saying 11 times 1, so that it's become easy for us also to see what was the total. I said 1, 1, 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, I forgot to, it became an infinite loop. We forgot to mention the shift. See here. So I accessed all the positional parameters using $1. So every time you use shift, the command line will be shifted by one position to the left. Like as I said, it's like a conveyor belt mechanism. You move elements from one station to another using that assembly line. So assume that my command line arguments are sitting on a conveyor belt. Every time I move the lever with a shift, the positional parameters will be shifted to the left by one position at a time, and then the remaining are available. Every time I use shift, the $hash will be reduced by 1. So initially when my program started, I have passed 15 parameters, command line arguments, but I can only access the first 9 with the direct special variable $1 to $9. What if I want to access 10, 11, 12, 13, 14, 15 and beyond? Then in that case, Every time I want to move them to the left, I will use one shift. So for the first time when I said $hash, it says 15. Then I use shift, I said $hash, this time it will result into 14. Again I said $hash, it will result into 13. So I keep on doing this until the $hash value itself is greater than or equal to 1. So as long as at least even there is a one parameter left, I want to switch to the shift by one positional parameter. And the moment there aren't any more parameters left, this is when my loop terminates, because there aren't any more parameters left. So if you visit this, so see how many times I am performing that iterative action. I am doing this until the command line argument count is greater than or equal to 1. So is 15 greater than equal to 1? Yes. 14 greater than equal to 1? So on. Is 2 greater than equal to 1? Yes. Is 1 greater than equal to 1? Yes. Now the moment I use shift, now there aren't any more parameters left. $hash automatically becomes 0. Then next time it comes, is 0 greater than or equal to 1? No. This is where my loop terminates and the control is passed on to the next statement after done, which prints the total of all the command line arguments that I have done. So very interesting technique to access command line arguments beyond position 9. So $@ or $* both can be used to print your command line arguments as is, just in case if you want. So people, they use another technique. They use a shortcut for this one. I wanted you to solve this particular exercise using a true while loop. But people, they use a shortcut technique, something like this. So I am modifying my program now slightly. Instead of putting a genuine logic of understanding this, people sometimes they use a shortcut. See what is the shortcut. Well, I never anticipated that you would be using this as a shortcut. So people say sum is equal to 0 for cmd arg in, which is my counter variable. What will $@ print? All the command line arguments as is, $@ or $. So this now becomes my list of values. And then people say do I am running it one more time. Clear? Well, this is an escape technique, because I know the entire command line can be accessed using $@ and I can then make use of that $@ as a list of values in a for loop. I am expecting you to solve it with a while loop, because while loop also clarifies the doubts about $hash, which for loop does not tell you. So every time I use a shift, the value of $hash reduces by 1. So this is why I expect you to run through the genuine loop. And what if I wanted to run, so I wanted to modify this shell script to print odd number of command line arguments only. So think of this thing. I want to print only the odd number of command line arguments. So I don't want, so if this is my command line, if this is my command line, let's say, it should only print the odd positional parameters 1, 3, 5, 7, 9, 11, 13 and 15. So think of this thing, like give it a try. What if I want to just print, skipping by 1, the odd number of positional parameters? This is just my program requirement, let's assume. So that was about the special variables available in Unix. I told you the reason. You cannot assign a user defined value to these variables. Now understand the way a shell script runs in Unix. User login process was initiated, means you typed in the IP address of the server with an SSH or a telnet connection. The authentication process was done. Unix assigns you a command shell. In my case, the command shell which was selected as my default command shell was bin bash, which is a bash command shell. So depending upon the user's preference, the command shell would be assigned. It could be bin, it could be bash, sh, corn shell, csh, or any other shell available, as long as you are comfortable to work with that shell and the shell itself as a program is installed in Unix. Then a user runs a script the way I ran the previous script. So I am on bash command prompt, which is also my login shell or a command shell, and that's where I initiated a user defined script. I want it to execute that. See what happens when you run a user defined script. The parent shell, which in my case is also my command shell, spawns a child shell depending on the shell directive. So which is my parent in my case? In my case, bash shell with the PID as 8575 is my parent, or also the command shell for that matter. When I ran this one, bash examines what is the shell directive given in your script. Depending upon the shell directive, it then calls that particular shell program, which in my case is KSH. So understand this, the parent shell spawns a child shell depending upon the shell directive. The child shell then runs the code in the script. So whatever code you have mentioned, who runs it? Bash never runs it, or for that matter my parent shell never runs it. So it spawns a child, the child runs the code. Once entire code has been executed, the child shell kills itself. It returns the control back to the parent. Until this happens, my parent shell will wait for my child to finish the execution. So understand it one more time. The child shell then runs the code in the script. Once all the code is executed, the child kills itself and returns the control back to the parent shell. Parent shell waits until the child shell finishes the execution. Once the child has killed itself, the control is back to the parent. Parent can now examine the exit status of the child, which is using $question mark. So this is how the whole execution happens in Unix. There are multiple questions as to why only this mechanism. Let's understand this in a better way. So I am again editing my program. This time I am adding slip 20 argument to it. I am opening another observation window and I want to find out all the processes owned by user Dick. So as of now, these are the only processes: the SSH connection that he has established, and 8575, which is the command shell of that user, and more in a better way, the father information of the process, the parent tree information. So it tells me 8574, which is my SSH session, is actually a parent for 8575, which is my bash shell, and bash in my case is my command shell. Now let's run as Dick the same program here. This time it will give me some more time for examining what's happening when I run that script. So I am ready with my command, and here I go, I run it. It is going to sleep for 20 seconds. So see which shell it has invoked. Now why it invoked a corn shell only? That is because of my shell directive that I have mentioned in the script. So understand this. SSH session has a PID of 8574, which is actually a parent for my bash, and bash is a parent for the child script that I have invoked now. The child script is being run in a corn shell. Now why this happened? It's because of the shell directive. I said head one of this one. So this is my shell directive which tells my parent shell which shell needs to be invoked as a child. So my bash, which is my command shell or a login shell or a parent shell for the child program that I am running, invokes a child shell called as KSH. KSH in turn then runs the program. Once all of the executable code from this script has been executed, corn shell will kill itself. This is the child. It returns back the control to my bash shell. Now that the fact that the shell script has finished, see here, no more I can see that corn shell. The parent in turn can now, well, I have typed it. Let's do it one more time. Now I am running it one more time. See, the PID last time was 15827. This time it is 15861. So there is no guarantee what will be the PID of the child program. It will keep on changing every now and then, even if you run the same program. After my child has finished, I can examine it from here. No more the child program is running. I can now examine on my parent shell the exit status. So the exit status indicates 0, which means the command's execution was successful. That's where I said put appropriate exit statuses in your script depending upon the logical outcome of it. Otherwise, any program that executes successfully in a child shell, the child shell will always return the status as 0 because entire execution has been completed flawlessly. So the child shell will always return a status as 0 to my calling shell. In my case, the parent shell is bash, which also happens to be my login or a command shell. How do I prove it one more time? So let's prove it this time. So I am commenting the logic part of it because I am not interested in executing it now. I am putting only one instruction this time into it. $$ I said is prints the PID of the shell where the $$ command itself is running. So understand this. I will copy this line. If I say echo $$, now see what it prints. It's the PID of the shell where I ran $$ command. So where did this $$ command run in this case? On my command shell in the bash. Now I run it the way I used to run it traditionally. See this time. Which also proves that my command script long cmd arg list.sh never ran in my parent shell. The parent in turn created a child. The child executed the code. The control was then given back to the parent, and that's why when I printed it from the command prompt, the PID was 8575. But when I am printing it from the child shell, it's printing me a different PID. Now see here, every time I run it, it prints me a different PID. So every time bash creates a child, which is of the type corn shell, the corn shell runs my instructions in the command, whatever in the user defined script I have mentioned. It executes it, kills itself, returns back that control back to the parent shell. In my case, that parent is a bash. So that's why every time I run this, it prints me a different PID. But no matter how many times I run the same thing here, it will always print me the same PID. Clear? So this is to prove the fact that the shell scripts are never run by the parent. They are being called by in a child shell which has a copied over environment, and the child shell runs it, returns back the control after execution back to the parent shell. Very important to know. Question is, well, I have understood this now, that my parent would never run it, my child script is going to run it. Question is, why? So understand it. When you run a shell script, the parent shell, which is also your command shell, spawns a child shell of the type bin ksh. Now it depends upon the shell directive. I am assuming my shell directive was # bin ksh. The child then runs the shell code. Upon completion, the child kills itself and hands over the control back to the parent shell. We have done a quick and a dirty test of this by saying $, and $, indeed proves that it was not being run by the parent shell, it was being run by the child shell. This is done to avoid an accidental kill of the parent shell in case of a buggy program. Assume that I would have run this code directly into the parent shell and my code would have been buggy. Buggy means an unwanted exit statement. From where I would have exited? I would have exited directly from the parent, my session would have terminated. However, if you prefer to run a script in the parent shell for some reason, there is a technique to run it. So see here. I am editing my program one more time. There is only one instruction. Exit. This is to indicate the bugginess of my script. Now assume that I am running this script in a child shell. To whom would that exit instruction apply to? To the child. Even if the child terminates, your control comes back to the parent. Will it cause any harm as such? No. So I am running it, nothing. I am still there, very pretty much alive. But what if I would have run, or Unix as a default technique would have run that script in the parent shell itself, then the exit would have applied to the parent, terminating my session itself. If I type an exit command here directly, see what happens. Well, let me open a duplicate one before. If I type an exit, see what happens. The command window itself disappeared because the exit instruction was applicable in this case to my command shell, and the command prompt is lost because of this. Now for some reason, if you want the script should run in your parent shell, then there is a way to do that. So for example, I am again editing long CMD line and I am removing this instruction, and instead I am running the same echo dollar statement, echo $, which prints the PID. If I run it like the traditional way, it will run it where my bash has a PID as 15961 this time, but this time it's not printing 15961 because it ran in a child shell. What if I want to run it here in the parent shell? So see here, I said dot space followed by absolute or relative path of the program. This time I have given a relative path. But what I said before that, dot space. That dot space indicates do not run it in a child shell, run it here. Here means in the parent shell. Now what will be the outcome of $? Outcome of $, should be this. So see here, this proves that the code was not run by a child, the code was indeed run by my parent. See one more time, see one more time, see one more time. Every time I run it, I am running it in the parent. But if I remove this dot space, that means run it in a traditional format. Parent giving a birth to the child, depending upon the shell directive, the shell will then run the code, kill itself at the end, will return back that control to the parent. If I run it using a traditional way, it gives me a different PID to prove this. Clear? Now question is, which are those cases when I am supposed to run a code in parent shell, and which are those cases when I am supposed to run it in a child shell? To understand this in a better way, understand the way a Unix variable works. So see it here. So this is a small discussion on Unix variables. So this is, let's finish this first, and then we'll move on to that variable declaration topic. This is done to avoid an accidental kill of the parent shell in case of a buggy program. However, if you prefer to run the shell script in the parent shell, you can do so by typing dot space followed by a relative or absolute part to the program. Clear? So this will run it in the parent shell itself. Use $$ to identify the PID of the shell. If you are in doubt whether you are running it in the parent shell or in a child shell, use $$ to determine which shell actually ran your code. Now understand the way variables work. So the next topic is user defined variables in Unix. When you define a variable, the scope of the variable is limited to the current shell only. Means wherever you have defined the variable is only accessible in the current shell. How do I prove this? So understand it one more time. I am in the parent shell. I said city is equal to Pune. I said echo $city. I can access the variable's value. Now I am writing a child shell. Access parent variable.sh. I am starting with hash exclamation bin ksh. I said echo the city is $city. Isn't it? If I say $city in parent shell, it was printing me Pune. Will it print the same thing in the child shell? Let's understand. I ran it using a traditional method. Means parent will create a child will run the code, and the only code I am running is the city is whatever. See what it prints. So it does not have an access to a variable which was defined in the parent shell. Why? When you define a variable, the scope of the variable is limited only to the current shell. I defined the variable where? In my parent shell. Parent shell was of the PID 15961. The parent shell program itself is bash. So the variable is visible in the parent but not in the child shell. That's why the variable was not accessible here. Clear? But if I run this script like this, then where I am running this script? In the parent. So parent will anyways have access to that variable. This time there is no problem. This is another way to prove it. That my command is now running in the parent shell, not in a child, which is a spawned shell from a parent shell. So variable once defined in Unix by default are only accessible within the current shell. I cannot access them in the child shell. Well, what if I want to access them? Then in that case, you can make a variable defined in the parent shell visible to all the child shells by exporting the variable. There is a way to make it visible, that is to export a variable. See here now. So city was not visible because it was not exported to the child. Now I say export state is equal to Maharashtra. Clear? What is the difference between the way I defined the city variable? City was never exported. Here the second variable state, which has a value as Maharashtra, has been exported. Let's modify the child shell now. The script. I am running it now. The traditional method. See here, city is not accessible, but state is accessible. Why? Because my parent said it can be exported to the child shell. So by default, the variable is never visible to the child shell until you export it. Once it is exported, all the child scripts can access to that variable. Clear? I am slightly modifying it. What if I run it in the current shell? Obviously then both the values will be printed. So city is Pune, state is Maharashtra. Clear? So this time there is no problem. Now understand one more thing. I am creating grandchild variable test dot sh. The grandchild says hash exclamation bin ksh. Again I will copy over the code. Clear? I am marking this script also as executable. Now I am editing my child, and from the child I am printing a message. See what I am doing? The child script is calling another child script. See what happens to the variables then. So I am running now in a traditional way. So access parent variables, city was not accessible because it was never exported. State was accessible by my child because the state variable was exported. Now it says now I am calling the child script. Who printed this message? Access parent variables dot sh. Now this is the code actually from the grandchild. So I said my name is grandchild variable test dot sh. City is still not accessible, but state is accessible. Now understand this. You can make a variable defined in the parent shell visible to all the child shells. All the child shells. So this was my direct child. This was my grandchild. Clear? So one script calling the other and still I can access it. Clear? So understand the scope of the variables. This is even more important. Now understand, is there anything called as a global variable in Unix? Typically people, they have a common question. Is there a global variable in Unix? Answer is no. There is no global variable. So what do we mean by a global variable? A global variable is defined in one shell, can be accessed from others, not it can just be accessed, it can also be modified. Well, there is no such global variable concept in shell scripting. Understand this one more time. Now I am editing access, and now I said I am running it now. City value is not accessible because the variable was never exported by the parent. State value is accessible. The state is Maharashtra. Child is now changing the value to MP. The state is now MP. Now call my child program. The grandchild is now running. City is, the city variable is still null. But see now what is the state variable? MP. Now what is the current value of that state? MP or Maharashtra? Understand this now. Echo dollar state. If this would have been a global variable, what value would have been visible here? Maharashtra, which is not the case. So a variable defined in parent can be accessed by child or a grandchild depending upon whether you exported it or not. The child can modify it. The child can see the modifications, but the modified value is not visible back into the parent. This is what I mean by global variables. So Unix does not have global variables which could be modified by any child scripts. A child script can always modify the variable defined in parent and exported to the child, but the modifications done to the value of these variables is not visible back to the parent shell. This is what I mean by that there doesn't exist a concept of a global variable in case of Unix shell script. So child can always modify it. I modified the value of state variable which was defined by parent in the child to a new value from Maharashtra to MP. The child and the grandchild was able to see it. But when I come back to the parent shell after the execution of the programs and I try to print out that value, the value is still Maharashtra. Now understand this one more time. What if I run it in the current shell now? So I am running the child in the current shell. So I done it this way. Nothing changed. The only change I want to see is now. Clear? Because the scripts ran in themselves in the parent shell where the modification happened. So I can't say that it was modified by child. It was modified in my current shell itself. That's why the new value is visible. Question now is, which scripts you consider to run it in the current shell and which one you run it in the child shell? There is a very simple technique. If your script contains variable declarations, which is like environment setting, then run this code in current shell. If your script contains logic or processing, then run it in the child shell. If it's only variable declarations, run it in the current shell so that all child will get an access to those variables. If it's only a logic building or if it's only some processing, then run it in a traditional method. So I want all my variables to be visible by all the child processes. Then I said vi vars.sh. I said export city is equal to Pune, export state is equal to Maharashtra. When I want to run this, I should run it ideally in a current shell because it does not have processing, it only has variable declaration. But if I want to run a child script, a processing logic, then run it using a traditional method. So see now, city was also visible, state was also visible, child is trying to modify the value of state from Maharashtra to MP. Child successfully modified it because this is the state called as MP, it's saying, although there is some typography error. It should have been is. It doesn't make any difference to the logic though. So when I am running it, the city is also visible. Maharashtra state, which was the value of the variable state exported by parent, is visible in the child. Child could successfully modify it. Child could pass on the modified value to its own child. But when I come back to the parent, it's back to Maharashtra. Clear? That's where I said there is no concept called as a global variable in case of Unix. So very important learning for understanding the variables. Now people say, how do I communicate a variable back? Write them to the files. If there is something that you want to do a persistent transfer from child to parent, then instead write a logic which writes that value in a persistent store. Persistent store is some file, whereas a variable is not persistent. So if my session is lost, if my system reboots, then I cannot transfer back that value. Anyways, there is no way by which a child can transfer that value back to the parent. Clear? So that's no way, there's no way otherwise. So when you want to enable a parent-child communication, enable it either via IPC pipes or using some persistent data store by writing those modified values into the file. So don't declare them as a variable if you want to move forward that variable to the child and get back the modified value from child back to the parent. So this could be, or another way could be using it as a command substitution. If the parent wants to define a variable, allow it to be modified by a child and the modified value should be visible to the parent, use command substitution. So even when the value is changed, the assignment is still happening into your parent shell. So it's an important technique now for